Welcome to the notes for 4-12. Today we're going to write equations of sine and cosine graphs. We've done graphing the equations in the past, so today we're going to kind of go the opposite direction. You're also going to look at writing the equations just given descriptions as well. So let's get started. It says, recall that the sine and cosine functions are really the same function. One is just shifted horizontally from the other. Okay, well, what does that mean? So let's just take a quick peek. I'm going to pull out my graphing calculator. Okay, so I have my calculator in radian mode. Okay, I have set my window. Oops, wrong one. I've set my window to go from 0 to 2 pi, right? That 6.28 is simply 2 pi. It'll change it on your calculator. And my scale, I did pi over 2. So I'm just trying to look at one period. So I'm going to do like pi divided by 2. You see it changes it to that 1.57 number. I have my y min is -1, my y max is 1, and then my y scale, or the increments it'll be going by, will be halves. Okay, so what I did is I took it and I typed in my sine function will appear in orange, my cosine function will appear in green. So when I look at my graph, this is what I see. And you can see here is my cosine function as it starts at the max, goes all the way down to the minimum, and then back through the midline up to the max. The sine function over here, right, starts on the midline and goes up and then down and then back up to the midline, right? And then it starts to repeat itself. So when it said that one was just shifted horizontally from the other, if we think about it, we could take either one of these graphs and shift it to make it overlap with the other function. So for instance here, if I look at my sine graph, and let's say it had been shifted, right, and we were trying to shift it so it was originally, on the green, it was originally that cosine function. We gotta think about how that would have shifted. Okay, well, right now everything is greater than the green graph, right? It looks like it's about pi over 2 greater than it there, so we have to think about how we would have to have shifted it back to where it would have originally been. So let's go into our y equals here, right? So if I wanted to shift that, okay, it looks like it's been shifted ahead. So what we would have to do then is we would have to add second pi divided by 2 in there. And when we graph that, you'll see now we only see one function because this graph that we see now would have been shifted back over. So so it's just 90 degrees, or pi over 2 is the difference between these two functions. Okay, and you have to make sure you're shifting it the right direction and everything there. We don't have to worry about that as much right now, but just making sure that we understand it's the same shape, just one is 90 degrees off. And you can think about it also looking at the unit circle too, how your points, right, when you think about your coordinates, over on the right side at 0 or 2 pi, right, we've got that point 1, 0, where we know the cosine of theta is the 1, and the sine of our angle would end up being 0. Well, then when we go 90 degrees up here, right, we're at that point 0, 1. Notice now our cosine of theta would be 0, and our sine of theta is now 1, right? So think about it. The difference here is that 90 degrees, or if we're talking about radians, that's that pi over 2. Okay, so that's what makes the difference between our sine and cosine graphs, but really they're both considered to be kind of like the same function, or they could be. All right, so it says we can classify both of these functions as sinusoidal functions. Okay, so it's just a big fancy word there that's just kind of representing all of them. So recall the general graphing form of a sinusoidal function as, and we have y is equal to a times the sine of b times the quantity of x minus h plus k. And actually I should not be highlighting x. Okay, so we got these 4 parameters, and those 4 parameters we know all will affect our graph in different ways. So today we're going to focus on how to take the information from a graph and be able to put it into an equation using these parameters. Let's get started. First one says, write an equation for a cosine function. So right now we know we're talking about a cosine with an amplitude of 3 a period of 2 and a vertical shift down 5. So I'm going to just list out those 4 parameters over here. We know that we're going to be finding A, we'll be looking for B, we'll be looking for H, and we'll be looking for K. Now, remember our A is just our amplitude, so I think we already know that the amplitude is 3, so we know that A is going to be 3. Now B, right, B is that part here that we see usually right out here in front of our x or our theta, so it's like the coefficient. Okay, if they tell us our period length is 2, we can use this to help us figure out what B is. Because remember, our period, or that period length, is always going to equal 2 pi divided by B. Okay, so if I know that my period is 2, right, I'm going to just substitute in 2 equals 2 pi over b, and then we can just use our properties of proportions, and we can actually just, flip-flop our 2 and our b, or you can cross multiply if you need to do that, but we're going to get b is equal to 2 pi over 2, which we know simplifies down to pi. So our value of b is pi. Now, it makes no mention of any horizontal shifting or phase shifting in this description, so we can just call that 0. And then it says a vertical shift of down 5, so we know that that means minus 5 for k. Now, as we look to put this all together, we're going to use the factored form of it first. Okay, so I'm going to focus on using the factored form first, and then we can simplify if we need to. Remember, our factored form is exactly what you saw in that last slide. So we're thinking of y is equal to a times I'm sorry, this is cosine on this one, so we'll use that. Cosine of b times a quantity of x or theta minus h, and then plus k. So we're just going to put in our values. We've got y equals 3 times the cosine of b being pi times a quantity of x minus 0, right, because there's our horizontal shift, and then we have plus k, so it'd be minus 5. And what you see in here, right, I'm just writing it in the factor form so you understand that part right there. Usually we wouldn't leave an x minus 0 in there. We'd simplify it down, and our answer would be y equals 3 times the cosine of either pi times x or pi times theta, just depending on what you used, minus 5. And that is the equation of the function that's described above. All right, next one says write an equation for a sinusoidal function with a range of -2 to 10, both included, and an angular frequency of 4 pi. Okay, so when it says sinusoidal function, right now we could pretty much use a sine or cosine. It doesn't really matter. But since we used cosine above, we'll go ahead and use the sine function on this one. So let's look at the description and the details they're giving us. They're telling us that the range is from -2 to 10. So if we visualize, here's our y-axis, here's our x-axis, and if I say that my range, or my lowest point there, my minimum is -2, and my maximum is 10, okay, so we know that our graph is going to oscillate or fluctuate between those. So we can find our midline, right? Our midline would be just equal to the average of the max and the min, right? So we'll do the min plus the max and divide it by 2. So we'll say here our minimum was -2, our maximum was 10. We add them together, we get 8, and then when we divide that by 2, we're going to get 4. So our midline is going to be at +4. Now remember, that is also going to be our k value. So if we took this and we drew in our midline, right, it would be at 4. All right, so another thing we can get from that then now is we can find our amplitude by looking at that distance between the midline and the maximum. You see that distance is 6. And I know it's not drawn to scale, but from 4 down to -2 would also be 6. So right now that we know our amplitude is equal to 6, okay, we haven't figured out B yet, we haven't figured out H yet, and we have figured out that our K value in this one is +4. Okay, so the next part here is figuring out B and H. Okay, so with B, you see that we have this description. It says the angular frequency of 4 pi. Now, we don't use that terminology very often. Really, that's kind of talking about over time. How is our graph changing over time? But in this case here, all I need you to know, or all you need to know this year, is that B is equal to our angular frequency. Okay, and we can use that to figure out our period length most of the time. Okay, but in this case, we don't really need to know what the period length is if we know what the angular frequency is. If it's 4 pi, that means that our B value is 4 pi. And again, there is no mention of any horizontal or phase shift, so we're going to go ahead and list that as 0, and then we're going to write our equation. We have y is equal to 6 times the sine of 4 pi, and then if you're writing in the factored form, you'd say times a theta minus 0. Then we close it, and then we would add 4. Or if you're good without having to do that and you just want to write it like this is totally fine. Any questions? Please make sure you reach out or mark them down on your paper. Let's move on. So the next one says write both a sine and a cosine function that would produce the graph below. So you're seeing there's a function now on a coordinate plane, and we're going to try to write the equation of it based on looking at it. Okay, so there's some questions we need to ask ourselves. Okay, as you see it kind of oscillating back and forth, it says, where is the midline? Well, we can always find the midline if we need to, right? We know that the maximum value is 4, the minimum value is -2, and if you want to do the algebra behind it, or I'm sorry, the arithmetic behind it, it would be saying here that our midline would be equal to 4 plus -2 divided by 2, which is going to be 1. So our midline, right, is at the line y equals 1, and remember that tells us that k equals 1. And I would actually just go ahead and draw that in. And if it doesn't look like it's splitting it in half, then you probably drew it in the wrong spot. Okay, from that we can figure out what our amplitude is, right? Because we can count from our midline up to our maximum, which is 3 units, or down to our minimum, which is also 3 units. So our amplitude is 3. And then our period length. To get our period length, I would take this and I would start at 0, and I would trace my function until I reach that point again where it's going to start over. So we go from 0 to 2 pi on this one, so that means that our period length would be 2 pi. Okay, so how's this going to help us? Well, again, let's look at, we're going to try to come up with our information. We know that A is 3. We know that our B value, well actually we don't know the B value, but we're going to find that. And then we're talking about H, and we'll talk about K. So K we already know is going to be 1. So we need to look at how to find B, and then we'll talk about our H. So thinking about our formula again, right, where period equals 2 pi divided by B, so we know B is going to equal 2 pi divided by the period length. So if we are told, or if we figured out here that our period was 2 pi, we're going to take it here and we're going to do 2 pi divided by 2 pi, which is going to give us 1. So B is just 1 in this case. And then for H, on this one, H is going to be what you make it. So if we're asked to find a sine function, okay, there's several possibilities that we could do. Right, remember, sine starts on the midline, so we could start here, we could start here, we could start here, we could start here, we could even start there. Okay, so there's probably going to be an infinite number of equations that would represent this graph. So you just need to choose one or two and come up with those equations. So let's do, how about, I'm going to do the one that's highlighted first, right? That yellow one. Okay, that goes right through here. So when I look at that, right, it's definitely a sine function. So we'll call this number 1, right? We'd say y is equal to, now in this case, our amplitude is still 3, but since we're going down first, we need to put that negative in there. And then we're going to say times the sine of our b value, we said was 1. So if you want to, if you're still not comfortable, you can write the 1 in there like the b, and then do your theta minus your phase shift. Well, your phase shift is 0, right? It hasn't moved. So we'll say minus 0. And then we'll have our k value, which would be plus 1. So we put it all together. That's really just y equals negative 3 times the sine of theta plus 1. Okay, so what if we chose then to do maybe, let's say, this one instead, right? We went here, and we're kind of writing the equation based on this first period. Well, we'll notice here that some things don't change. We have y is going to equal, amplitude is still 3, but now it starts going up first, so it's got to be a positive 3. We'll do times the sine. Now, our period length is not going to change, so b here is not going to change. So I'm going to go ahead and just put my theta in. And then we need to figure out how far has this been shifted, right? So if it was at 0 here and we went all the way back here and started now at negative pi, remember it's like theta minus negative pi, which would give us plus pi. And then we would take it and add our 1 onto the back. So there's a second possibility. Remember, there's probably like 5 different possibilities you could see just right there. Let's do a couple of the cosine functions now. Okay, so if we look at cosine, all right, so this will be like our first cosine, right? We could start either up here, down here, up here, down here, up here, or even down there. So I'm going to go ahead and start with, let's do this one first. Let's do from here down, I'm going to just color over the pink. We're going to make it black there. So it's a positive cosine function. And we know that the amplitude is still 3. We'll multiply it times the cosine. And then we've got on this one, our b value is still going to be 1. So we're going to say theta. And then which way has this been shifted? Well, originally, right, we would have liked to have had it up here. So it went to the left. What is that? Pi over 2 units. So if we want to shift something left, we have to make sure we're adding. So plus pi over 2. And then plus 1. We'll do one more here. We'll do a negative cosine function. Right, so just find a point on there. I'll do this side. Let's shift this one right. So we're going to kind of look at this function. So again, y is equal to, now it has to be a negative 3 times the cosine. And we'll have theta. And in this case, it's shifted forward, it looks like. So we're going to say minus pi over 2 and then plus 1. Hopefully that makes sense. There's plenty more that you could find on that one. All right, so let's do another one. It says write the equation of a sinusoidal function that would produce the graph below. So when I look at this one here, it kind of jumps out to me that, hey, this is a cosine function right here. So let's go ahead here and identify what we need to identify. First thing, okay, let's look at where is the midline going to be. Let's draw that in. So this is a positive 1. This is a negative 3. When we add those together, right, to get our k is going to equal 1 plus negative 3 divided by 2 is going to be negative 2 over 2, or negative 1. So let's just draw in that midline. So right now we know k equals negative 1. All right, so we're going to need to find our amplitude. our B value, our angular frequency, we've got our H, and we've got our K. So for A, right, our amplitude, we can see here that there's 1, there's 2. We already know K is at -1. Okay. Our B value and our H value, well, first of all, in order to find our B value, we're going to need to know what the period is. So if we started here, and actually let me get a different highlighter. If we started here and we go all the way through the function and we stop right there, how far have we gone? Well, we've gone from -2 pi to 2 pi, which is going to be 4 pi. So our period is equal to 4 pi. So again, we'll just use that formula that the period is equal to 2 pi over our B value. We'll go ahead and use our properties of proportions. B is equal to 2 pi over 4 pi. Those cancel this down, and it should be 1/2. So B is going to be 1/2. And then for H, we just need to figure out where we want to start it. So I'm going to do this cosine function that's down here. So I'm going to start it right down here in this corner. And you can see originally, right, it would have been starting at 0, and so it shifted all the way back to -2 pi. So when we take this and we want to write it out, right, we're going to say y is going to equal, okay, our -2, right, because our amplitude, because it's been flipped, and then we've got times, I'm sorry, I forgot my actual trig word. Let's put that in there. So we have times, we'll say the cosine, because that's what it looks like. And we'll say here our B value is 1/2 times theta. And then if it's back here at -2 pi.
Please have Shan Trusley, Brandon Allen, Matt Sherpa, and Elizabeth Robinson stop by the front office, please. Shan Trusley, Brandon Allen, Matt Sherpa, Elizabeth Robinson. Thank you.
Sorry about that. Hopefully you're still able to follow along there, right? We shifted it left to -2 pi, so we have +2 pi in there. Okay, so remember, this is the correct answer, right? This is our factored form, and this is the easiest way to go, in my opinion. Okay, now, there is another form of this equation. If you don't want to have it in factored form, you might think about this, right? If I took it and I distributed my 1/2 through, I'd have 1/2 theta plus pi minus 1. But remember, that makes it harder to see your shifts from left to right because it looks like it's only at pi, but we've gone back to 2 pi. Okay, so these are both correct, but this is the one that I like. This is the one you probably should try to do first. All right, then we got the last one. It says, write the equation of a sinusoidal function that will model the height of an object that oscillates between 4 feet above ground when t is equal to 5 seconds and 1 foot above the ground when t is equal to 7 seconds. So with this one, we're going to have to draw ourselves a little picture. So I'm going to draw in my x-axis. Okay, I'm going to draw in my y-axis. And let's see, the information they gave us says that the sinusoidal function, okay, is going to oscillate between 4 feet when there's 5 seconds have gone by and 1 foot when 7 seconds has gone by. So let's go ahead and label our graph here. We've got some tick marks here. This would be 1, 2, 3, 4, 5, 6, 7. Heck, we might even throw an 8 on there just in case. So we have 8 little tick marks here. Remember, this is representing our time in seconds. And then it says that it's oscillating between 1 feet and 4 feet. So we'll go, there's 1, there's 2, there's 3, there's 4. Okay, so we know that this is the max, this is the minimum. So to find our midline, we can average those, right? We'd say 4 plus 1 divided by 2 would be 5 over 2, or 2.5. So that is exactly where our midline is going to be. So we can take that, we can sketch in our midline. Okay, and now let's just take it here and let's plot down a couple of those points that we've got. So we said at 5 seconds, right, it's 4 feet high. So that's the highest point, right? And then at 7 seconds, it's down to 1 foot. So when you think about it, if this is our max right here, and this one is our min, right, and they're basically 2 seconds apart, that means in the middle, right, it should be hitting there at 6 seconds, or that on that midline. And then after we hit the minimum, right, we're going back up to the midline, and then we can just keep going back, right? So going from right to left, we hit the max, we hit the midline, we hit the minimum, back to the midline, back to the max, and then back to the midline, which was, remember, 2.5. So you can kind of see your function. Okay, so they want us to find the equation. So now that we've got a graph to look at, we can pull out the information that we need. So first of all, our k value is obviously going to be 2.5. Our a value would be the difference between 4 and 2.5, which I think is about 1.5. And then our, let's see, we got KH, we got to look at our period length. Well, it looks like if we started right here and we went through, we would end right here before we start repeating ourselves. So that looks like a distance of 4. So our period, right, is going to equal 4 units, okay, or 4 feet. Okay, so if we think about our little formula there, right, remember period is equal to 2 pi over b. So since this is the same thing as the period, we're going to put that in for our period, and we've got 4 equals 2 pi. I think I said 6 there. I meant b. I don't know why I said that. Over b. Flip-flop, we've got b is equal to 2 pi over 4, which simplifies to just pi over 2. So that's our b value. So we know b, we know k, we know a, and then the only other thing there would be to find our h. So if I'm going to write this equation, I'm going to go all the way back here and use this because this is on the y-axis, right? So we don't have to worry about a horizontal shift. You can use any point you want there as long as it makes sense, but I'm going to use this one. So my answer is going to be y equals, my a value we said was 1.5, and then we have times our, oops, not c, it would be a sine function of our b value, which was pi over 2, and then we have times our theta. Okay, so theta would be, were we adding or subtracting anything? Nope, so if you want to put minus 0, you can, otherwise you can just leave it like that. And then we're going to say plus 2.5. And then you can simplify it if you need to. So either of those answers would be correct. All right, so you'll definitely have one of those on your test, so make sure you're practicing them in the homework when you get them. If you have additional questions, please make sure you reach out.